So guys, just like last time, I would like to start off by just going over one of the homework problems. I know it's a little bit tricky with me not being there, not being able to answer homework questions and things like that. So if you could get your homework out, the one that I want to look at is number 27. And like I said, I am trying to anticipate your needs. I'm sure you guys have questions on 42, but that's something that we could probably go over when I get back, and it's something that would be really, really helpful just to look at that story problem that we did, because it's almost going to be term for term, of course, with different numbers, but it's set up the exact same way as that story problem was in the notes. And remember, of course, that these videos, they're on YouTube. You can watch them at home, just like you have been the last couple of weeks. So 27 I thought was kind of an interesting one, and that's because it's in reverse order from standard form. So I wanted to kind of talk about that and just, figure out exactly what that means when it's in reverse order, because I don't want it to freak you out even if something is in a different order from what you're used to. So when we talk about these formulas, like the formula for the vertex and, what's A, what's B, what's C, things like that, what I want you to remember is that it doesn't always go A first and then B and then C. It's all about what it's attached to. All right, so I need to grab some colored markers. So like we talked about in the last video, the A is whatever is attached to the x squared. So the A is not necessarily the first term right here, it's whatever is attached to the x squared. So here, A is actually a -2, because again, that's what is attached to the x squared. And then B is a -4. B is always going to be whatever is attached to the x, and then C is the constant that's kind of hanging out on its own. So in this one, we're in total reverse order, so it goes C and then B and then A, so just be careful with that. So let's look at what we needed to see for the homework. So first we want to determine whether each function has a maximum or a minimum. So A is -2. And -2 is, of course, less than 0. So if something's less than 0, it's going to be one of these parabolas that are kind of flipped upside down like this. And so if a parabola is flipped upside down, then its vertex is going to be a maximum. So the first question that we can answer is saying that it's a maximum rather than a minimum. And then we want to find that value. So the way we find that value is we're going to find the x-coordinate of the vertex. That formula is -b over 2a. And so again, we need to be very careful knowing which one's A, which one's B, because we're in a different order from standard form. So -b would be a -4, and then over 2 times A, 2 times -2. So, of course, -4 just becomes a +4. So I have 4 over 2 times -2 is a -4, and that reduces down to a -1. So that is my x-coordinate. So that means that this line right here, x equals -1, is my axis of symmetry. I know that the vertex is going to lie on the axis of symmetry. And so I want to know what's the function value when x equals -1. So I try to find the function value when x equals -1. So that's what that notation means. What I do, remember this from the last lesson, is I just replace every x with a -1, like that one and that one. So replace the x with a -1, let's simplify up here. So 5, and then minus a -4, and then minus, this is going to be just 2 times 1. -1 squared is just 1. So 5 plus 4 is 9, minus 2 is 7. So that is the value that we're looking for. So first question was it's a max. Next question was that its value is 7. And then finally, state the domain and range of the function. So we just found that this coordinate point was -1, 7. So that tells us the very, very highest point on the graph. So starting with domain should be easy. You might have even just written this down right away before you even really thought about it or did any of the work. For the most part, with these continuous functions that we're seeing, the domain is going to be all reals. Now the range is what we need to think about. This is the y values. So when we're flipped upside down, we have a maximum value, meaning my graph can go all the way up to y equals 7, but no higher. And I can be anything below that. So 7 is the highest. I can plot any y value below that. So what I say is that y can be anything less than or equal to 7, no higher than 7, because again, that is my maximum. So just one example of the homework, so hopefully that is helpful. We are going to carry on with 4.2, and this is a calculator active section. So I did warn the sub that you guys would need your calculators. Hopefully everybody has them. So 4.2, we start off with a couple of definitions. We've been talking about quadratics, so let's just define a couple of things right here. So quadratic equations, these are quadratic functions that are set equal to a value. Quadratic functions that are set equal to a value. So again, we have talked about standard forms. The standard form of a quadratic equation looks like this. So now notice the key difference here, so I'm going to kind of block this off. This is our standard form. The key difference here is that a quadratic function is y equals ax squared plus bx plus c. Here, this is a quadratic function, which is what we know to be the left-hand side here, set equal to a value. Something like 0. It could be set equal to 10 or negative 20, but there is no y in a quadratic equation. It's the normal left-hand side standard form, but it's set equal to a number instead of being y equals. So that's the big difference, functions versus equations. The root of the equation is the solution of a quadratic equation. So the roots are the solutions of the quadratic equation. Okay, so the solutions, we use roots and solutions interchangeably. We will also use x-intercepts. We will use zeros. So I've got a couple of vocabulary words that really mean the same thing, and I'll make sure that I clear that up as we come across those words. So the roots of a function are the solutions, and remember the solutions are the values that make an equation true. So there are x values that if I plug them in here, they will make this equation true. There are of course many, many more x values that I could plug in and make the equation false. So just like solutions of linear equations that we've seen so far, the solutions are the ones that make it true. So we're going to solve these by graphing, meaning we are pretty much using our calculator for this kind of first round of solving. So that's why I wanted to make sure that you guys had your calculator. If you don't, please make sure that you're either watching me very carefully and then kind of watching the video at home to make sure you know what you're doing, or you need to be looking on someone else's. So solve each equation by graphing. So first thing, we are going to look at a new document and we're going to add a graph page. Okay, so the first thing that I want us to do is we need to be able to figure out exactly what the solutions are, so I want us to add in a grid. So we've done this before, so hit the menu key. Okay, the menu key over on the right-hand side, and then we are going to change the view, so that is the second menu there, so hit the number 2 to change the view, and again, we've done this before. And then we're going to add a grid, which is number 6, and then we want it to be a lined grid. So we've seen this before. It makes our graph look just like graph paper. It's wonderful. We can count out exactly where the solution is. So right now, you should have f1 of x highlighted. If this is a brand new graph page, then that should be what's up so far. If you don't have this cursor open, just hit the tab key and it should open it for you. So what we are going to do is we are going to just type this right in. We are going to type in x. The squared key is right next to the 4. And then plus 2x minus 15. Okay, so let me explain exactly what this means. We want this value, like when I plug these in, we want to get a value of 0. In other words, we want to get a y value of 0. So what that means is if we're looking at a graph, we want it to be an x-intercept. So before we graph, let's make a couple notes right here. Setting it equal to 0. Setting equal to 0 means we want to come up with an x-intercept. We've done that before. We've plugged in 0 for y and then solved for x. So setting it equal to 0 means that we are trying to find the x-intercept of this graph. That is our goal, and that is why we are about to hit enter and see what this function looks like. So again, we are looking for the x-intercepts of the graph. And I say intercepts because it is possible to have more than one when we're dealing with a parabola. So hit enter. Okay, so there's our graph. Now our parabola, it dipped down a little bit lower than the window that I'm in. It's fine. You can zoom out if it's really important to you to see it, but you don't need to because like I said, our goal is to find the x-intercepts. In the window that we're in, we can see the x-intercepts perfectly clearly. All right, so the graph that we've got in front of us, we have an x-intercept right here, 1, 2, 3. There's an x-intercept at 3, and then back here at negative 1, 2, 3, 4, 5. Okay, so that's what we're looking for. Those are our two x-intercepts. Let me just get a quick sketch of the graph. Okay, so we had an x-intercept at 3, we had an x-intercept at -5, and then we know it kind of dipped down below what we saw, but we can, we're just estimating, so we can turn it around whenever we want. So those are our two x-intercepts. So the solutions are just the x-intercepts. So we just write x equals 3 and x equals -5. Those are the two x-intercepts, and those are the two solutions that will make this equation true. So just one time, let's run through kind of the calculator check here. So if you turn that calculator back on, I drew on the screen, open up a graph page. So hit Control and then the document key. Add a calculator page. So we're going to test our first solution. That's the x equals 3 that we got. So type in 3 and then hit Control variable. We are going to store that in as x. Okay, and then hit enter. And then we're going to type this equation exactly as it stands. So x squared plus 2x minus 15 equals 0. So if it's a solution, that means that this will be a true statement. So hit enter. We get a true. That means that 3 works. Let's check the -5 as well. So -5, store that in as x, hit enter. And then remember, you don't have to retype. You can just arrow up a couple times, highlight, hit enter to paste, enter to check again, and -5 also makes the statement true. So that means that these two are our solutions. Okay, let's look at another one. This is slightly different. Here we have a -12 on the right-hand side. In order to solve by graphing, we need to get our equation in standard form. This is standard form. Everything is on the left, and there's just a 0 on the right. So again, everything needs to be on the left. This needs to be just a 0. So what I'm going to start off by doing is adding 12 to both sides. Okay, so I have x squared minus 8x plus 12 equals 0. So that's how I know I'm in standard form. So I am going to go back into my graph. So to switch pages, you can add a brand new page if you want, or hit Control and arrow over to the left to go back into our graph. So currently we have a different graph that's up right now. What we do is we hit Tab, arrow up, and I can just clear this out. So if I hit Control Delete, it'll just clear it, and then I'll be able to type in a new one. So now I want to type in x squared minus 8x plus 12. And again, by setting it equal to 0, what I'm looking for is the x-intercepts of the graph. Okay, so hit enter. That's my new graph. You can see it shifted around slightly. I'm still looking for my x-intercepts. So if I count over from the origin, here's the first time that I hit the x-axis. That is 1, 2 units over. And then 3, 4, 5, 6 is my second one. So I've got 2 x-intercepts, one at 2 and one at 6. So just so that you have a sketch to go off of if you're looking at your notes later, 1, 2, 3, 4, 5, 6. And this doesn't need to be the most beautiful sketch in the world. We just want to see what it looks like so that we understand that these 2 x-intercepts are our 2 solutions. So we get x equals 2 as well as x equals 6. So those are the 2 solutions. Those are the 2 x-intercepts of this graph right here. Okay, so let's turn the page, see what else we've got. Okay, so there are 3 possible outcomes when you're graphing a quadratic equation. You could have 2 solutions. You could have 1 solution. Or you could have no solution. Let me give you a quick sketch. So 2 solutions is just like we saw. It could go like this, and then it crosses through the x-axis once, and then it comes back and it crosses through again. Let me show you an alternate graph, because it could also go upside down. So that orange graph also has 2 solutions. Okay, 1 solution, this is kind of an interesting case. Now keep in mind, your graph could be right side up or upside down. This is just going to be one example. 1 solution means it comes down or up, touches the x-axis just in one point right here, and then it bounces back off. It doesn't go through. If it goes through, you have 2 solutions. So that's one way to have 1 solution. No solution at all would be if your graph, kind of comes through but turns back around before it even gets to the x-axis, or it could do the same thing like that. So those are 2 different graphs. Neither one of them have a solution because they never ever cross the x-axis. Okay, so another one of these. This one, remember, we need to be in standard form. So the stuff that's over on the left, we're going to add it over. So add 8x and then add 11. So these cancel, so I have 0 on the right-hand side, which is exactly what I needed. I have an x squared, and then I have an 8x, And then 5 and 11, when I add those together, I get 16. So now that it's in standard form, I can plug it in. So I'm going to go back into that same graph page. So calculator on. So I'm on the graph page right now. So remember to switch it out. You hit the tab key, arrow up, and then just hit Control Delete. So again, Control Delete to clear it out. And then we can type in this new equation. So x squared plus 8x plus 16. Hit enter. Okay, so now this is one of these examples that I was just talking about. Can you see that it comes down? It hits the x-axis, but it only hits it once, and then it bounces right back off and goes up again. So it only has one solution, and that one solution is -1, -2, -3, -4. So it only has one solution. Let's get a quick sketch again. 2, 3, 4. So it looks like this. And again, we're just doing a quick sketch that, you know, when you're studying, when you're looking back over your notes, you know where in the world that -4 came from. So it only has a single solution. All right, so now we're going to look at something slightly different here. Use a quadratic equation to find two real numbers with a sum of 6 and a product of -55. All right, so these two real numbers, we've got two different numbers. If they have a sum of 15, so let's say the first number is x. And then if they have a sum of 6, then the second number would be 6 minus x. So, you know, say the first one was 1, the next one would be 5 minus 1. I'm sorry, 6 minus 1. If the first number was 4, the second number would be 6 minus 4. That way, when you add them together, you get 6. So the first number will be x, the second number will be 6 minus x, because we know they have a sum of 6. And then they have a product of -55. So when I take x and I multiply it by 6 minus x, I'm supposed to get -55. So I can clean this up. I'm going to solve for it. So on the left-hand side, I have an x that I need to distribute. So I have x times 6, that's 6x. And then I have x times -x, that's a -x squared, equals a -55. So let's get this back in order. So standard form says I should have my -x squared first, then my positive 6x. And then finally, to be in standard form, I have to add that 55 over to the left. Equals 0. So here's my equation right here. So I'm just going to solve by graphing, just like I did with the previous 2 or 3 examples. So I am going to plug this in. So same thing, hit tab, arrow up and clear out that last equation. Oops, let's get my dot off here. And then type in this equation. So negative x squared. Always make sure you hit negative rather than the subtraction key. Plus 6x plus 55 and hit enter. So we are looking for the two x-intercepts. So I've got one right here. This looks like -5. That is one of my x-intercepts. So what I'm going to do is that's actually enough just to know that -5 is my answer. So x equals -5 is the one that turned out to work. And so if my first number is -5, that means my second number is 6 minus a -5. So my two numbers are -5 and 11. So let's clear those up. So two real numbers that have a sum of 6. If I add these together, -5 and positive 11 does give me a sum of 6 and a product of -55. If I multiply these two together, I get a product of 55. So I found my two numbers. Okay, last thing that we're going to look at here is estimating solutions. The problems that we just saw, we had these beautiful, perfect solutions that went right through the grid. These ones, not so good. All we're going to do is state the integers between which the roots are located. So let's start with this. We're going to solve this one by graphing. So same exact thing that I have done multiple times now. In my graph, I'm going to hit tab, arrow up, and clear the last one out by hitting Control Delete. And I'm going to type in this equation on the left-hand side. I'm looking for x-intercepts. So x squared minus x minus 10. Okay, so get that equation plugged in and hit enter. Okay, so now I want to make sure we can see this clearly. So I'm just going to do a pseudo zoom here. So they do not go nice and neatly through the x-intercepts. I've got one right here. And this one, here's 1, 2, 3. So it's in between 3 and 4. So that's my first one. So I can say that my x is somewhere, actually, let's just use a less than because we know it's not 3. So it's somewhere in between 3 and 4. And Then I have another one. Here is -1, -2. So somewhere in between -2 and -3. So we just do something like that. So again, quick sketch of our graph just so you can see. So between 3 and 4 and -2 and 3. So it went through like somewhere right around there, somewhere right around here. So it went through those points, but they weren't integers. That was not my best parabola. All right. So quick thing right here, you can also solve by using a table of values. So let's do the same thing. This is going to be our last one, I think. Let's plug this one in. I don't want to blow your mind with that story problem. It's already bad enough not being there. All right, so clear this one out. So let's type in x squared minus 6x plus 2, and then hit enter. So to use a table of values, here's one thing that I want to point out. These values right here are all positive values of y, and then I hit 0, and then I go below the x-axis. So those are negative values of y. And then I cross through at 0, and then these are positive values of y. So what happens right here is I switch from positive to negative values of y. And then what happens right here is I switch from negative to positive values. So I'm going to use our table to come up with those values. So hit Control and then T, and then we'll get a table of values. So if we look, let's scroll up a little bit. So here I have positive x values, which means I'm above the x-axis, I'm above the x-axis, above the x-axis. Oh, there's a negative value, so that means I'm below the x-axis. So what must have happened is that somewhere in between 0 and 1, I must have crossed through the x-axis. So let's write our first one. So 0, so x is somewhere between 0 and 1, just ignore this. And then our next one, we scroll down, so now I'm below the x-axis, below the x-axis, below the x-axis, below the x-axis, below. Oh, and then all of a sudden, let's look at these two. So this negative number tells me I'm still below. This positive number tells me I'm now above. So somewhere in between 5 and 6, I must have passed through. So my next one is somewhere in between 5 and 6. All right, so let's confirm. So hit Control T again, and it'll close that table out. So we said somewhere between 0 and 1. Yep, that looks about right. And then somewhere between 5 and 6. Also looks about right. Okay, so again, we are just going to skip over this. Like I said, I think it's a little bit difficult enough with me not being there. I don't want to dive into a crazy story problem. All right, work hard.